Wow.
What's good, guys? We're gonna be continuing lesson 3.1. What we did yesterday, the video, most recent video, is this is just a continuation. So here we go.
Hi. That applause better be for me, Jesse.
Okay.
No?
Sure.
Okay, I teach the whole lesson. He says one thing, he gets an applause.
Yes.
What kind of appreciation is
I'll go
that?
over a
I
video
have no
over
respect.
a YouTube. I'll give 2%.
2%? Okay, yes, when I make a
1,000
half of a
subs.
cent, yeah.
When you're 2000.
Yeah, when I have 73 right now, so I don't see that happening anytime soon. Okay, all right, here we go. No more comments, no more talking. We're gonna review the second example, just because it was a lot. Remember how we were talking about the difference between a continuous domain and a discrete domain? How did I write the word continuous?
Perfect.
Cursive.
I forgot what those are.
Yeah, I'll go over it. I'm getting good at writing this cursive. I haven't done this since like 5th grade.
Oh, yeah.
Okay, so I write my word continuous in cursive just as kind of a little mental model so we can remember that the continuous line of the cursive signifies the continuous line of the domain. Because remember, the pool that's being filled up, remember it's kind of like starting a stopwatch and then turning the hose on?
Oh yeah.
It's not just about the water that's being thrown into the pool
The money.
at each minute. It's talking about a continuous flow of water in between all those minutes too. Those tenths of a second, those hundredths of a second, boys, if you could pay attention, that would be great.
Okay.
So we have a continuous domain because the time is continuing. It's not just hopping from minute to minute. Here, this is our discrete domain, which I kind of wrote, oh, what's happening to my marker? That was more of a rhetorical question. So I have my discrete domain, and I write this to signify that each domain interval is its own value, and it cannot have any value in between these domains. And why is that? Do you guys remember this example from yesterday? Emily?
It hops from point to point.
Yes, it hops from point to point, but more according to the information on the graph. What is it?
Kind of looks like a number one.
Right, but we're talking about the number of what?
Tables.
Tables. And you can't have 1.36 tables, right? Unless you got out your chainsaw and started cutting things up. But why would you do that when you're just ordering chairs for your restaurant? You're ordering 4 chairs per table. So you're jumping from 1 table to 2 tables to 3 tables to 4. And you're ordering chairs for each of those tables. So your domain, jumping from 1 to 2 to 3, doesn't have any values in between your intervals. It just has values at each interval. There's no continuation between them. Do you guys understand what a discrete domain is? It hops from interval to interval instead of continuing through the intervals. Because
What's an interval?
this example is where you're basically recording the time on a stopwatch. This isn't really what's happening, but if you think of it that way, you're like, I'm about to fill up a 10,000 gallon pool. And somebody's standing there with their stopwatch, and somebody's standing there at the hose about to turn the dial, and he goes, 1, 2, 3, go! And he turns the dial and starts the stopwatch. And the entire time the stopwatch is moving, the hose is filling up. So you can pick a point at like 1. Now this is 1 on the graph, but it's in terms of 100 minutes per interval that you see. So this 1 would actually represent 100 minutes. So if you look at the stopwatch at 100 minutes, it has a certain amount of water filled up. But there was also water being filled up in between all of those minutes and all of those seconds, because water's continually filling it up. So as the water continually fills it up in between all of those minutes and even those seconds, right, or hundredths of a second, thousandths of a second, it's filling up. The domain is all of those real numbers, all of those decimal numbers and fractions. Now here, the restaurant is ordering chairs for a certain number of whole number tables, because they're not saying, well, at our restaurant, some of our tables will be cut in half, some of our tables will be cut in thirds. You know, we're not actually trying to order chairs for parts of a table. So every time we order a table, it hops from one table to 2 tables to 3 tables. We're not trying to go, okay, from this 1 table to 2 tables, how many chairs should we get? We wouldn't be trying to get chairs for a half of a table. So it's simply a discrete domain. It's just hopping from whole number to whole number, or from interval to interval. Whole numbers in this case, but it doesn't necessarily have to be just whole numbers. Okay, so are you guys good? Now, this is a little bit funny. Now, I am actually looking into this to see if this is an error, because I do believe that there's an inconsistency here, and I would love for you guys to try it for a Jolly Rancher. Do not just start guessing. Okay? Do not just start. I'm going to give a little more information. I will call on you first. Okay? Don't be disappointed, because I'm still going to call on you first, but I do want everybody else to get an opportunity to think about it. We are comparing the time that is passing as our domain with how much water is filling up this pool. I'm going to extend this graph just a little bit, because technically it did say that in the previous slide here, it does say that the pool is filling up at a rate of 10 gallons per minute. So technically, we could actually solve.
Attention teachers and students, please pardon the interruption. In just a few minutes, we will be running a severe weather drill. Teachers, at this time, if you could please review your crisis management plan, and also you were sent an email specific to this drill and where you will need to report. So if you could please check that in the next couple of minutes before we start our drill. Thank you so much.
Okay, just so you guys know, I will have to end this video and restart it, because I will need, not yet, we're still going to record. As soon as the drill starts, you can press end on the video. This video will be in 2 parts. Not yet, not yet. I'll tell you when. I just want to, when they give the drill, you can end it, okay? And then we'll continue. So just to realize that they are giving us the rate, and we do have a stopping point for how much this pool can actually be filled up. We don't want to exceed 10,000 gallons, or else the pool will overflow. Right? So I know you guys are thinking about the drill right now, but I still want you to pay attention to this. Which is more important for your test?
Good.
Okay, good. So everybody's paying attention, right? Okay, so we can actually make a little proportion to determine, well, how much time is it actually going to take to fill up this whole 10,000 gallon? So if I have a rate of 10 gallons per 1 minute, and I want to set that equal, or find out how much time it will take to go from 10 gallons to 10,000. Whoops.
Attention teachers and learners. This is only a drill.